Hey guys, I am Avilash Ravi, currently pursuing my BTech in Computer Science at VIT Chennai. Today I will be elaborating on the topic quote unquote applications of CFG in speech recognition. So let's get started. So these are all the contents of this presentation which I will be covering. I will first brief you on an introductory aspect on CFG, speech recognition and some major applications, and discussing on the application aspects, language modeling, parsing, error correction, speech synthesis. These are some 4 applications which I have shortlisted and I will be explaining in this presentation. I will also conclude the presentation by mentioning some of the future directions of CFG in speech recognition. So let's get started. Introduction. So what is CFG? CFG stands for context-free grammar. Context-free grammar can be defined as a 4-tuple notation where G is equal to V, T, P and S. So G is the grammar which consists of a set of production rules. It is used to generate the string for a language. And P is the final set of terminal symbols. V is the final set of non-terminal symbols and P is a set of production rules. And last but not the least, S is the start symbol which is used to derive the string. We can derive the string by repeatedly replacing a non-terminal by the right hand side of the production rule until all the non-terminals have been replaced by terminal symbols. That's the definition of CFG. Also, I have provided an example for 0 plus 1 the whole star regular expressions. I think the production rules are self-explanatory as it will generate any number of zeros and ones. Moving on to the next slide. Speech recognition. So what is speech recognition? Speech recognition is the capability which enables a program to process human speech into a written format. CFGs are particularly useful for tasks such as parsing, disambiguation, where they can help to identify the correct interpretation of a spoken sentence. So the importance of CFG plays a key role in speech recognition in order to convey a meaningful output of text by converting the speech as input. Moving on to the next slide. Major applications of CFG in speech recognition. So the 4 applications which I will be elaborating in this presentation are language modeling, parsing, error correction, speech synthesis. All these I will be discussing in detail in the following slides. Language modeling. So what is language modeling? Language modeling refers to the process of predicting the next word or sequence of words in a given sentence based on the context of preceding words. So there are several aspects which determines language modeling. Generating n-grams. N-grams are sequences of n-words that are commonly used to model the probability of a given word in its given context. So rule-based probability modeling is another aspect where CFG is used to define the probability distribution over the space of possible sentences. The third aspect is contextual understanding, where the CFG is used to help these speech recognition systems understand the context in which the words and phrases are used. So in the right hand side, I have attached a language modeling animation which rearranges a sentence to provide a meaningful meaning that has to be conveyed. Moving on to the next application, parsing. So what is parsing? Parsing refers to the process of analyzing a spoken sentence and breaking it down into its constituent parts, including words, phrases, and clauses. The context-free grammar is used in parsing in 1, 2, and 3. 3 major ways. The first way is defining grammar rules. CFG is used to define the rules for a sentence structure, including the order of words, types of phrases, and the relationship between words and phrases. The second aspect is parsing algorithms. As algorithm means step-by-step procedures, CFG is used in parsing algorithms that take a spoken sentence as input and output a structured representation of a sentence. These algorithms use CFG rules to build a parse tree which represents the syntactic nature of the sentence. The third aspect is natural language processing, which is used for helping speech recognition systems understand the meaning of the spoken sentence by analyzing its structure and identifying the relationship between the words and phrases. So as you can see, I have attached an animation for dependency parsing in the right hand side and a parse tree that shows the division of a sentence into articles, nouns, verbs, subjects, noun phrases, etc. In a parse tree modeling. As you can see, the words are separated based on their parts of speech, and the above example, the dependency parsing, shows the stack that gets incremented sequentially and derivations are done based on the production rules. So that's parsing. Moving on, error correction. I hope the term is self-explanatory. Error correction. What is error correction? Error correction refers to the process of detecting and correcting errors in a spoken language, such as grammar and syntax errors. So some of the major aspects in this application is modeling the common errors. CFG is used to model the patterns of common errors that occur in spoken language. This indicates the word order, the tense, the verbs, the subject-verb agreement, and all aspects. Error detection is the ability to detect the error in the spoken language by comparing the input to a set of grammar rules or the context-free grammars. If the input violates one of these rules, the error is detected. And as you know, error correction, we apply the detected errors and correct them by applying a set of grammar rules to the input to generate a possible corrections for the given output. So naturalness improvement. CFG is used to improve the naturalness of a spoken language by identifying and correcting errors that can make the language sound unnatural or irregular. So such corrections can be made under this application. Moving on, I'll be showing you guys an animation of error correction. As you can see, quote unquote, the use of history fact as a springboard for fiction is not a new one. So this sentence is corrected by the following animation. And in the right hand side, I have attached the production rules for the normal English grammar consists of noun phrases and verb phrases. So based on the production rules, the correction is done. And there you go. The final sentence is corrected. Moving on. Speech synthesis is the fourth application I will be explaining. What is speech synthesis? Speech synthesis refers to the process of generating speech from a text input. CFG is used in speech synthesis in the following ways. Text to phenome conversion. The process to convert the text input into a sequence of phonemes, which are the basic units of sound language, is a major deal that has to be considered while doing the speech synthesis. Prosody modeling. I will show you a real-time demonstration of this in the following slides. Prosody refers to the patterns of stress, intonation, and rhythm in speech. CFG is used to model the prosody of the synthesized speech by defining the rules for placement of stress and modulation of pitch and duration. Synthesizer control. This I will also elaborate on this using a real-time example in Python. It is nothing but the property of the voice that will be generating and other parameters that affect the quality of the synthesized speech. And naturalness improvement as well here. The CFG modeling is effective by generating patterns of the natural language, including grammar, syntax, and disclosure structure. So that's about speech synthesis. So let me now move on to the real-time demonstration using Python and in PyCharm IDE by implementing the pytdsx3 module, the Python text-to-speech shortly. Hey guys, so this is the real-time demonstration that I will be giving you on the speech synthesizer topic. So there are two major types of speech synthesis. One is the prosody model. Prosody model is nothing but the intonation or the rhythm or the slang that we speak. It varies from people to people, country and regions. So let me just demonstrate that in PyCharm, where I'm using PyTT-SX3, the Python text-to-speech module, which is used for converting a text input to speech or audio. It generates a voice. So let me just show you. So first I want to tell you by saying that let me just remove all the punctuations from this input and run the code.
Hello sir, how may I help you, sir?
Okay, so you would have heard the voice. So it just bluntly read the input which I have given in the program. Okay, now let me just give the punctuation.
Hello sir, how may I help you, sir?
So hello sir, there was a pause. How may I help you? There was a pause, and then sir. So that is nothing but the prosody modeling, the intonation, the pause which is required for every punctuation. In PyTT-SX3 module, in the module code they would have written a CFG. For the comma you have to give a pause. So that would have been the instruction in the module. That's why when we execute this program, we are getting a pause. This is known as prosody modeling. Now coming to the synthesizer control. Synthesizer control is nothing but the property of the voice. So here we have the engine.set property tab, and voice, under voice parameter we have voice and ID. So now let's just change it to 1.
Hello sir, how may I help you, sir?
So you would have spotted the difference now. Initially it was a male voice, now it was a female voice. So we have changed the property of the voice. This change in property is said to be known as synthesizer control. So now again let's change it to 0.
Hello sir, how may I help you, sir?
Yeah, so we get the same male voice back. So the change in property is said to be known as synthesizer control, and the intonation or rhythm through which we speak is said to be known as prosody modeling. These two are the major types that determines speech synthesis. And yeah, so let's go back to the slides. Conclusion. So in conclusion of this presentation, I'll be discussing the future aspects of CFG in speech recognition and summarize what we have learned in this presentation as well. Future directions of CFG in speech recognition. A CFG based feature extraction is one of the major aspects of future. CFG can be used to extract features from spoken sentences that can be used to improve speech recognition accuracy. And the next aspect is CFG based adaptation. The CFG is used to adapt speech recognition systems to new languages or domains. This is because CFG can be used to generate language models for new languages or domains which can be used to train speech recognition systems and process modules. CFG based deep learning. Well, AI, machine learning and deep learning is the future. So CFG can be used in conjunction with deep learning techniques such as recurrent neural networks RNNs and transformers to improve the accuracy of speech. For example, CFG can be used to generate training data for RNNs and transformers which can be used to improve their performance on speech recognition tasks. So these are some future directions of CFG in speech recognition. Moving on, let's summarize what we have discussed in this presentation. So CFG stands for context-free grammar. It is a formal grammar which is used to generate all possible patterns of strings in a given language. Speech recognition is the capability which enables a program to process human speech into a written formats. So we discussed 4 major applications of CFG in speech recognition: language modeling, parsing, error correction, and speech synthesis. And we also discussed the future aspects as well. Those are CFG based feature extraction, CFG based adaptation, CFG based deep learning applications. And thank you guys. Thank you for watching my video. Hope the video was informative. You can share this video, comment and like as well. Do follow me on Instagram and LinkedIn. I have provided my links in the description. Thank you. Cheers.